Hello to everyone. I am Professor Raja, working as Assistant Professor, EC Department, SNS College of Technology and Autonomous Institution, Coimbatore. In this YouTube video, I am going to discuss the 19 ECB 301 Analog and Digital Communication subject under the topic Vestigial Sideband. So, if you watch my previous playlist, this playlist video, you may know about what is meant by communication and what are the communication and how modulation is done and what is the need for modulation. Without modulation, what are the drawbacks that can occur. Also, I discussed the various comparisons of pulse modulation techniques, then discussed the pulse amplitude modulation, pulse position modulation, pulse width modulation. In this video, I am going to discuss the vestigial sideband, which is the updated of double sideband full carrier. Vestigial sideband modulation is a type of amplitude modulation technique that is commonly used in television broadcasting. It is a compromise between full double sideband and single sideband modulation. Double sideband AM, it involves transmitting the carrier along with both the upper and lower sidebands, which are mirror images of each other and contain the same information. Single sideband, that is AM, only one of the sidebands, either upper or lower, is transmitted along with a reduced or suppressed carrier. This method is more bandwidth efficient but complex to implement in double sideband. Vestigial sideband modulation, both of the sidebands are not required for the transmission as it is a waste, but a single band is transmitted leads to loss of information. Vestigial sideband modulation or VSB modulation is the process where a part of the signal called vestiges is modulated along with one sideband. A VSB signal can be plotted as shown in the figure. If you see the figure, x-axis shows the frequency, y-axis shows the amplitude. The USB upper sideband is shown in the right hand side and the part of lower sideband is also added with this upper sideband. In order to avoid interference, a guard band is attached at the end of the upper sidebands. Along with the upper sideband, a part of the lower sideband is also being transmitted in this technique. A guard band of very small width is laid on each side of the VSB in order to avoid the interferences. VSB modulation is mostly used in television transmissions. Now we go to see the advantages and drawbacks. The main advantages of VSB are highly efficient, reduction in bandwidth, filter design is easy as high accuracy is not needed. The transmission of low frequency component is possible without difficulty, possesses good phase characteristics. It combines the benefit of DSP and SSB. It conserves bandwidth like SSB while maintaining some of the simplicity of DSP. Drawbacks: bandwidth when compared to SSB is greater, demodulation is very high and complex. So some of the real-time applications of VSB modulations are: the most prominent and standard application of VSB is for the transmission of television signals. Also, this is the most convenient and efficient technique when bandwidth usage is considered. If you watch my previous YouTube video, you clearly understood what is in by amplitude modulation or double sideband full carrier. When we derived the efficiency of double sideband full carrier, the total efficiency will be 33.33. Since most of the power are wasted in carrier and sidebands, one of the carrier is suppressed and the term called double sideband suppressed carrier. If you can derive the power efficiency of double sideband suppressed carrier, that will show a efficiency of 66.67. That is also not satisfied. So both the sidebands contain same information, so I will remove one of the sidebands. So that term is called single sideband suppressor carrier, and the transmission efficiency of that single sideband suppressor carrier is 83.33. Now in this YouTube video we discussed VSB. Since one of the sideband is damaged or due to some noises, the information is damaged, so in order to recover the transmitted image, in part of one sideband along with a part of the other sideband is also attached. If you see this figure, upper sideband is fully transmitted and along with a part of lower sideband also attached. So this will recover whatever the noises in the information, and it will give the 100% transmission efficiency from sender to the receiver. Now we discussed the applications, advantage, drawbacks, name of the activity. So based on my YouTube video, you may have some comparisons. So that also I have discussed at the previous YouTube video. Next video I will discuss with you some new topics. Thank you for watching my video.